Question 18 says a magnetic dipole of dipole moment m vector is placed at the origin as shown. A quarter circular conductor is rotated about y-axis with angular speed omega. The induced EMF across two ends of conductor is given as E is equal to mu naught m omega by n pi r. Then find the value of n. Okay, so we have this magnetic dipole placed parallel to y-axis as shown. As far as the concepts are concerned, we need to find magnetic field due to this magnetic dipole, and due to that magnetic field and rotation of this conductor, we have to find the induced EMF. So electromagnetic induction is also involved here. So we look at the magnetic field produced by this dipole, and for doing that, let's draw the figure again. So this is our conductor and this is our magnetic dipole moment m. So what we do is we take angle theta from the x-axis and resolve m. We draw this along this radius vector because we consider a small element on the conductor. So let's say this angle is d theta and the length of the conductor has become r d theta. Length of the element has become r d theta. So if I look at m, I resolve m in these two directions parallel to the r vector of this element and perpendicular to that vector. So if this angle is theta, this angle is also theta, and this dipole moment is then m cos theta and this dipole moment is m sin theta. Okay. Now if we look at magnetic field here due to this part, these two parts, well, magnetic field due to m cos theta is in this direction. It will be tangential to the element that we have drawn. Okay, and since this is tangential to this length, the induced EMF due to this part of field in this element is 0, and this is true for all the elements. So we can see that this component of magnetic moment is not producing any induced EMF in the conductor. Let's look at the other component. Now due to m sin theta, the field here is in this direction, and that field B is equal to mu naught by 4 pi 2 times m sin theta divided by r cube. This is the field, and this field is perpendicular to the length and the velocity of the element. So this will produce induced EMF. So we now find induced EMF in this element. We call it dE. So the expression for dE then is, now we can apply BLV term. So B we have, L will be r d theta, and V is, in fact, we have to consider that the velocity is omega into this length, and this length is, we can see that it is r cos theta, right? So this length is r cos theta. So dE is B, which is mu naught by 4 pi into 2m sin theta divided by r cube. This is B. L becomes r d theta, and V is omega into r cos theta. Now another thing important here is that all these three things, that means the B vector, the length and velocity vector, are mutually perpendicular, so we can apply this expression. This is EMF across the small element, so to find the total EMF we can integrate, and the value of theta will go from 0 to pi by 2. Let us simplify this further. So we can see that this r square cancels, and we have, then this 2 can be struck off also. So this is equal to mu naught m omega sin theta cos theta d theta, and let the 2 be here. We have here 4 pi r. Okay, and we need to integrate. Theta goes from 0 to pi by 2. I have kept 2 here because then this expression within the integration sign, it becomes sine 2 theta. So this EMF then becomes mu naught m omega by 4 pi r, and this is integral of sine 2 theta d theta. So we have integral sine 2 theta d theta as minus cos 2 theta by 2 and the limit goes from 0 to pi by 2. So this will be 2. So this effectively the induced EMF is coming out to be mu naught m omega divided by 4 pi r. Now if I compare it with the given expression, we can see that the value of n is clearly 4, and as per the format of the question we can give the answer as 04, right? Let's go to the next question now. Question 19 says 3 identical slits are arranged as shown. If small d is much smaller than capital D and BP minus AP is lambda by 4, then intensity at P is Ni naught, where I naught is intensity due to each individual slit. Find the value of N. We have been given that BP minus AP is lambda by 4. Now we can also say that BP minus AP is equal to, the length BP will be under root of capital D square plus small d square, and whereas AP is simply D. Now this we can take D square outside, and then we have D into 1 plus small d square by capital D square to the power 1 by 2 minus D, and we can use binomial approximation. Then if we do that, this is coming out to be equal to D square by 2D, and this is given as lambda by 4 to us. So let's use this result. Let's also find Cp minus AP. So now to find Cp minus AP, again the path difference, that is equal to under root capital D square plus 2D whole square, that means 4D square minus D, and this again is equal to capital D into 1 plus 4D square by capital D square to the power 1 by 2 minus D, which further simplifies to 2D square by capital D. Now if this length was lambda by 4, this is obviously 4 times of this, so this is equal to lambda. Now we have to find expression for intensity at P. So what we do is we draw 3 phasors, right? We superpose these waves at point P. So the wave from slit A, let's represent it as this. Let's say the amplitude is E naught, and the second one is at path difference lambda by 4. So if I convert it into phase difference, phi 1 will be equal to 2 pi by lambda into lambda by 4, and this is coming out to be pi by 2. So we have another one, again E naught at pi by 2, and the wave coming from C will be in phase with this. So there is another E naught here. So we get 2 E naught and E naught, and if I apply the Pythagoras theorem, the amplitude here is coming out to be root 5 E naught. So the intensity is proportional to 5 E naught square. So for E naught intensity is I naught, that means here the intensity is equal to 5 I naught, which means answer to this question, the value of N is coming out to be 0.5. Let's now go to the last question of this test. Question 20 says 2 particles A, Ma 2q, and B, Mb 4q are accelerated through potential difference V and 4V respectively. They enter in a transverse uniform magnetic field and follow circular trajectory of radii r and 2r respectively. Find the value of Mb by Ma. Okay, so the radii have been given, and energy of the particles, the kinetic energy of particles has also been given in a way. We can see that kinetic energy of particle A, Ka, is 2q into V, that means 2qV, and kinetic energy for particle B, Kb, we can see that it is equal to 4q into 4V, that means 16qV. Okay, it's given to us. Now we have to find the ratio of their masses. Now radius of a charged particle which is performing circular motion in a uniform magnetic field, R, is given as mv by qb. Okay, so this is general expression. We can put these expressions in terms of kinetic energy because it's momentum v. The momentum can be written as under root of 2 times mass of the particle, it's into its kinetic energy, and of course divided by charge, into B. So this means that capital R by 2 times capital R, this is RA by RB, is equal to, this is say RA by RB, and this is equal to under root of 2 times mass of A, let's put as mass of A, into kinetic energy of A, which we can simply put as 2qV divided by charge of this particle, which is 2q, and B, and this divided by radius of the second particle, which is, well, we are short on space on the right hand side, so I am just writing it here itself. It is then under root of 2 times mass of B, and charge here is 4q, and in fact kinetic energy here is 16qB. So this is not B, it is V here. This is V here, right? So 2 MB into 16 QV divided by charge, which is 4Q into B. So this means 1 by 2 is equal to under root C MA and 4 QV. So QV term will cancel. So it's 4 and divided by under root MB into 32, and 2 QB is the denominator and this will go to the numerator, so into 2. So this further simplifies to 1 by 2 is equal to under root MA by MB 1 by root 8 into 2. Let's square both sides, and if we do that we get 1 by 4 is equal to MA by MB into 4 by 8, or MA by MB is equal to 1 by 2, but we have to find value of MB by MA. So value of MB by MA is then 2. So that means for question 20 our answer is 02. Well students, with that we come to the end of this quick solution. I hope you found the solutions useful. I wish you all the very best. Take care and bye.